Hello, today we'll be starting about signals and systems subject. So we'll be seeing different operations and different type of signals. How do we perform the operations on the signals? So as we move ahead, so basically a rule called as the precedence rule. Precedence, spelling may be wrong. Precedence rule is followed for different operations on the signal. So what are the basic operations on the signals? So as far as the operations on signals is concerned, okay, so primarily we have certain signal functions. So the signal functions will revise a bit. So one signal function is basically this. This is called the unit step function. Okay. So as you can see, I'll draw with a different color over there. So yeah. So this is the amplitude. This is the amplitude of this signal, which I've drawn in black. You can see over here. So this amplitude of this signal, this is the amplitude. Suppose this amplitude A is equal to 1. So we call this as a unit step function. And here this is the time axis. This is the time axis. So that means your amplitude, this function is represented amplitude is equal to 1 when you can notice when time is equal to 0, right? So here you can see the value, this time value equal to 0. We refer this as the present time. This is the start time. Okay, and the futuristic time is time greater than 0. Okay, this is the future. Okay, future time. Okay, and the previous time or the past time, past. Okay, past time is time less than 0. So you can clearly see this signal does not exist right here. The magnitude A is equal to 0, right, for this period. So we can say A exists, A is equal to 1 for t is equal to 0 or t greater than 0, and A value is equal to 0 for t less than 0. So this is a unit step function. Okay. Similarly, as you can see over here, we have some basic functions. So this was a step function, and if the value of A is equal to 1, then it's called unit step. If any other value, then we refer to it as a step function. Okay. A step signal. Same way we have an impulse signal here. An impulse signal is just like a shock wave. Impulse signal is like a shock wave. Impulse signal is like shock wave. Shock wave. Okay. So basically, in signals and systems, what we are seeing, this is our system. H refers to the system. And to this system, we give some input. Here we are giving some input and three primary inputs. One is your impulse, another one is your step function. Okay. And you can give a ramp, you can give a parabolic input, and you can check the response. What is the response? This response here, which is referred as y of t, response which is referred as y of t, okay, and input is referred as x of t. Now what happens here, this system is the output response, that is your y of t, y of t, okay, y of t divided by your x of t. Okay, so here you get basically this is your network function. From this impulse signal, when you are mentioning, impulse signal will exist only for the value. Okay, it will have an infinite energy. This signal is lambda of t, and it exists only at the present time, that is t is equal to 0. This is the time where the signal exists, only for this time. Sorry, only for this time. Other than this time, the value of the signal is 0, right? Other than this time, the value of the signal would be 0. So you can clearly say that the unit impulse signal value is infinity at t is equal to 0, and other than t, the value of the signal is 0. So if you need to reflect this signal, so what we need to do here, okay, so we can say that this lambda of t is equal to infinite at t is equal to 0 and is 0 if t is greater than 0 and t is less than 0. So these two conditions can be reflected when t is not equal to 0, because this represents the condition t is not equal to 0. So you saw this. So this signal can again be expressed like lambda of t can be again expressed in terms of If you want to get this function, so you just integrate the signal from minus infinity to plus infinity. Okay, the value of dt would be equal to 1. So this integration refers to the area of the signal. Okay, and this is basically your platform. So this is infinity, this is the sky is the limit. Okay, एंड हियर माइनस इन्फिनिटी, ये है आपका पाताल लोक, जमीन के भी नीचे। और ये जीरो जहां पर आप एग्जिस्ट कर रहे हो, ये आपकी धरती है, प्रेजेंट कंडीशन। आपको कल क्या होगा वो फ्यूचर है, टी ग्रेटर देन जीरो फ्यूचर है। और कल से जो पहले हुआ है टी लेस देन जीरो वो पास्ट है। ठीक है, ये बेसिकली आपको दिमाग में रखनी है बात। अब आप जाओ रैंप सिग्नल के बारे में, जो आपका तीसरा सिग्नल है रैंप सिग्नल। अब जब आप रैंप सिग्नल पे जाते हो तो रैंप सिग्नल आपका ये सिग्नल है, देखिए ये स्ट्रेट लाइन है। तो अगर यहाँ पर मैंने एक पॉइंट लिया, लेट्स से x1, और यहाँ पर मैंने एक पॉइंट लिया y1, ठीक है। इसी तरीके से यहाँ पर एक डॉट लिया, ये हो गया y2, और ये हो गया x2, सो ऑन एंड सो फोर्थ। यहाँ पर आगे आप जाते गए यहाँ पर लेट्स से यू गॉट द लास्ट पॉइंट एज xn एंड हियर इन यू गॉट दिस एज yn, इस पॉइंट पे yn। तो अगर आप रैंप सिग्नल को देख रहे हैं तो एक स्ट्रेट लैम्प रैंप रिप्रेजेंट कर रही है। अब इसका स्लोप क्या होगा? स्लोप किसी भी सिग्नल का आप निकालते हो y2 माइनस y1 डिवाइड बाय x2 माइनस x1, यानी कि दिस इज बेसिकली dy बाई dx। कभी आप लिखते हो dy, कभी आप लिखते हो डेल y बाई डेल x, है ना, या dy बाई dx, और कभी इसको ऐसे भी लिखा जाएगा डेल y बाई डेल x। तो ये जो ऑपरेटर्स है डेल डी और ये, दीज आर द सेम डिफरेंशिएटिंग ऑफ ऑपरेटर्स। ठीक है, डिफरेंशिएटिंग और सब्ट्रैक्टिंग ऑपरेटर्स, तो इसमें कंफ्यूज नहीं होना चाहिए, सब्ट्रैक्टिंग ऑपरेटर्स। और यहां से आपको मिलता है स्लोप किसी भी सिग्नल का, ये आपको जैसे इसका स्लोप निकालना है आपको। ठीक है, तो आप यहाँ पर देखो, अगर मैंने इसको y1 को रखा 1, ठीक है, इसको मैग्नीट्यूड मैंने दिया है यहाँ पर, इसका 1 है, लेट्स से y1 इज 1 एंड दिस इज ओके। सेम हियर, दिस इज योर 1 and this, it has to be 1 and 2, it has to be same value, 1 and 1. Okay, so this is your x1 y1, and then you have x2 y2 as 2 and 2 points, then only a straight line will be formed. Now if you just carefully look the slope, so 2 minus 1, again 2 minus 1, so dy by dx, the slope of this signal you can see is clearly equal to 1, correct? This is the slope of this signal that you are getting. And this signal, basically if you have to express this signal, x of t is equal to a of t. If the value of a is equal to 1, we say it is a unit ramp. Okay, we say it is a unit ramp. And this signal, again, you can see, if I plot the future and the past values here, right? So this t less than 0 is the past, and t is equal to 0 is the present, and t greater than 0 is the future value. So you see, this signal primarily is existing for the present and the future values. It's not existing for the previous value. So t less than 0, again the signal value is 0. So we can combine this t future and 0, and t less than 0, the value of this amplitude is equal to 0, right? If a is equal to 1, then this signal will become t and 0 for t greater than 0 and t less than 0. Okay, this was about the ramp signal. Now let's discuss about the parabolic signal. Parabolic, parabolic signal. Okay, so the parabolic signal exists like a parabola, like it is existing. Okay, like this, and this value of the signal x of t is given by a t square by 2. Okay, again this signal is existing not for the previous values t greater than or equal to 0, and the value of the signal for less than 0 is this. Now these were some primary signals. Okay, and the fourth, see we have discussed the three, this was the fourth, right? Now the fifth signal here which we'll be using is rectangular pulse, rectangular pulse signal. So how does this rectangular pulse signal exist? So this is basically a rectangle which has a dimension here minus t by 2, and here t by 2 on this side. So it's a square pulse, you can see, and this is 0 value, this is 1 value. Now if you see The value of the signal is existing only for the period between minus t by 2 and this is the value, right? It is only existing. So amplitude is equal to 1 when the time is greater than minus t by 2, and when the time is, so it is existing between these 2 points. Okay, at any other point when your t is either less than minus t by 2, right? So this is your time now, this line is your time. So here less than t by 2 it is 0, and if it is greater than t by 2, again your amplitude here is 0, correct? Amplitude here is 0. So this is again 0 if the t is greater than t by 2. Okay, so this was about the rectangular pulse signal. And similarly, you have a signal called as a triangular pulse. Like rectangular pulse, same way you have a triangular pulse. So you just draw this triangle over here. So this is your minus A, this is your plus A. Okay, so now you see this signal again is existing for only the period. Now here you have to take the slope of the signal, right? So delta A of t, the slope of this would be equal to 1 minus t by A. That is, t is existing for less than equal to A, and for t greater than A, this value is 0, right? So it is existing between minus A and A, right? Less than or equal to A. Okay. Other than that, if the slope is here and here, it would be 0. Then one more function that you are getting is signum function. Signum signal. Now the signum signal is basically represented by, see, if you carefully analyze this signal is, okay, called the signal. Its value is 1, right? So signum of t is equal to 1, where when time is equal to 0 and greater than 0, right? T is greater than 0 and equal to 0. Okay, and its value is equal to minus 1 when t is less than or equal to 0. So this is your signum signal. And also you notice here, okay, same way, let's first understand how do we operate on these signals. Okay, so uh, see, first we will be understanding amplitude scaling. Okay, there are certain operations, time scaling, okay, and addition, multiplication, like we have two or more signals, how do we add it, multiply it, subtract it, okay, and fold it, okay, or time folding, or shift it folding. Okay, so let's get and understand what about the amplitude. Okay, suppose if I have a signal, unit step signal, I want to shift its amplitude. So I'll multiply 2 u of t. So what u of t normally represented me like this, okay, where the magnitude was equal to 1, a was equal to 1. So if I multiply this 2 into u of t, this outside the parenthesis, this was only change the magnitude of the signal. Okay, it only changes the magnitude. Instead of a there, a becoming, so this a value will change. A will be equal to 2. Rest all the signal remains the same. So basically this is the meaning of the amplitude scaling of any signal. Okay. Now let's say I have to time scale the signals. Okay. So amplitudes, if I write minus 2 u of t, right? What it's going to do? You have it, you just multiply it with minus 2. So what happens to the signal? Instead of C, the value of the signal A will become equal to minus 2, right? So minus 2 comes down. Minus 2, just want to change the color here. Yeah, this is not looking pretty. So minus 2 comes down here. So the signal value here will become, it will go down here. So this will become A is equal to minus 2. So this is your minus 2 u of t. Okay. So amplitude scaling is symmetrical about the y-axis. This is your y-axis, you see. So I can write a point, amplitude, okay. Amplitude scaling is symmetrical around the y-axis. Symmetrical around y-axis. Y-axis. Okay. Now let's understand when we will be applying the precedence rule and all. I'll explain you how do you make the signal and all. Now, these time scaling versions, okay, if you have a signal and you want to time scale it, you want to multiply it with any part, like for example, you have a unit step signal like this, okay, u of t. Now, inside the parenthesis, you want to write u into 2 of t. What this is going to do is, it's going to divide the time, okay. So suppose this was equal to your 1, this was equal to your 2, and let's say this was equal to your 4. So u2 of t will divide, so you just have to divide the whole signal by 2. And now your new signal will start 0, and also 0 by 2 will be 0 only, but the signal will be right here. See, suppose the signal was here. So this value here will become zero point 0.5, this value will become 1, and this value which was at 4, it will become 2. So multiplication results in compression of time. Multiplying inside the parenthesis, multiplying inside the parenthesis results in compression of the signal. Okay, compression of the signal. And now suppose you have to write u of minus 2t. See, now notice minus 2t. Now this minus will create a mirror image of the signal. Create a mirror image. Mirror image only on the time axis. See, whatever value was at 0.5, it will go to minus 0.5. So the signal will shift. It will go like this. So this is minus 0.5, minus 1, and minus 2. So you just see it is creating a mirror image of the signal. Mirror image of the signal. Okay. And also you notice this time whenever you are performing time scaling operation, it is symmetrical around the x-axis. You notice here this is the x-axis. So this time scaling is symmetric, okay, symmetric around the y-axis, around x-axis, sorry, around x-axis. Okay, so this was about the time scaling, and this operation x of minus t, u of minus t, is basically called the folding operation. Okay, folding operation. If you have divided the signal, it will result into expansion. If you do x of u of t by 2, okay, now whatever the signal was there, right, it was like this, u of t was this was at 1, 2, and 4. Okay, now the signal will expand. U t by 2 division will result into multiplication in the time axis. Division will result in multiplication in the time axis. Multiplication in time axis. In time axis. So here you notice this signal is now going to move here from here. So this value will become 1 into 2, 2, okay, 4 and 8. So you see this signal expanded. Okay, this signal expanded. Okay, now if you want to delay a signal, if you want to write ut minus 3, okay, so u of t started here. U of t started here, u of t. Now t minus 3 is a delay. It will result into a right shift by 3 units. Suppose this was your 0, this was your 1, this was your 2, and this was your 3. Now the signal starts at 3 and continues. Okay. Now the modification u of 2 minus 3 is amplitude is equal to 1, where when t is, okay, greater than or equal to 3. Okay, 0 otherwise. Okay, if this condition is not followed, to if t is less than or equal to 3. Okay, this signal had u of t. This was amplitude was equal to 1 when t was greater than equal to 0, and it was amplitude was equal to 0 when t was less than 0. So this is the shift there in the signal. So this is called delay in the signal. Delay in the signal is causing a right shift. Delay in the signal causes a right shift. Causes a right shift. Okay, right shift. Now, as far as another process is good, now again this delay and all Only amplitude is symmetric around the y-axis. It pulls you down around the y-axis. Whereas all the other functions till now, what we have seen, now if I do ut plus 3, it will result in a right shift. Simply, if there is written plus 3, you just minus from the function here. So the signal starts from here. So 0 minus 3. So the signal starts from here, minus 3. Okay, this is the value of ut plus 3. So you see here what it did. Sorry, this did a right hand side shift. This resulted in a left hand side shift. Left hand side shift. Okay, this was your time advanced signal. Time advanced signal. Now, for example, if you want to add these signals, if you want to write u of t minus 3 plus u of t plus 3, correct? So you notice, okay, here when you're adding, these values are 0, 0, 0, right? So, and here between minus 3 and 0, if you're moving, the signal value is remaining what? Signal value is 1. So minus 3 and 0, the signal will remain same. Minus 3 to 0, the value of the signal will remain same. But as you come to 0, this value is 1. Okay. Here also at 0, t is equal to 0, this value is 1. So this 1 and 1 will add. You are getting my point. So now your signal, if you are adding this signal, so this 1 no longer remains 1. Where the signal will go? See, minus 3 up till as you move, right? So at t is equal to 0, this value is 1. Okay. At t is equal to, so this will move to 2, right? So this signal is moving to 2 at 0, right? At minus 3 plus 0 minus 2, this is 0, minus 1 also 0, and suddenly the signal is spiking up. Hmm? Where it is spiking up? Here. So this signal, if you want to draw, like this, you will draw. Okay, this value is 1 here, and suddenly this peaks up, right? It goes to amplitude, goes to 2, right? And it stays at 2. It stays at 2, correct? 2. Till where? Till infinity, because this unit step is moving till infinity, right? So it is moving till like this. Okay, now let's do some examples here. Okay, and let's understand how do we do and make the signals and different signals. Hmm? And let's understand clearly the concepts with regarding to this with the unit step, and let me also show you with the ramp functions and how we will be doing. Okay, now if you notice here, okay, you have a signal, hmm, whose impulse function is del t. If you want to get the integration of this, right, the differentiation of impulse signal would be 0, because differentiation of a constant is equal to c. Now here the integration of this x of t would be integration of x of t dt. Okay, and the differentiation is basically dx of, differentiation is dx of t by dt. Now for the impulse signal, this does not exist, but this value becomes equal to 1. Now as far as the unit step signal is concerned, hmm, so differentiation and integration, right? So if you integrate the unit step signal, it becomes a ramp signal. Okay, this becomes a ramp. Okay, integration of a unit step signal results into a ramp signal, and differentiation of a unit step signal results into an impulse function. Impulse function. Similarly, if there is a ramp signal, this was impulse. Okay, this was your unit step, and this was your ramp signal. रैंप सो रैंप को अगर आप डिफरेंशिएट करोगे डी डी ऑफ टी बाई ओके सो इफ यू डू dt of the ramp signal r of t will result into a unit step signal, and integration of a ramp will result into a parabolic signal, that is t square by 2 parabolic signal. So these are important functions there which you have to keep in mind. Now we have seen with the unit step, let's see with the ramp function. R of t is a ramp function. Okay, so ramp function, we notice that it starts from here, right? This is my ramp function. Okay, so let me take this value, this as 1 and this as 1, and the other value, let me take this as 2 and this as 2. So I take this value as x1, the other value as x2, this value I take as y1, this value I take as y2. Now if I need to get the slope of this, That slope is dy by dx, as I told you before. That is the final value, that is y2 minus y1 initial value, x2 minus x1. Okay, these are my values. So if I want to get the slope straight away, 2 minus 1 divided by 2 minus 1. So this is 1. Slope here is 1. Now the same signal, if I want to write r is equal to 2 ramp of t, correct? So it will shift the amplitude, right? Now whatever the value was there, right, at 0 it was there. Okay, so that means x will be equal to 2 times y. So if it is 1 at y, it will be the value. So here if it was 1 and 2, so here it will go to 2. Okay, so this would be the point. So it will become twice of it. So whatever the value would be there at 4, at 2 the value would be 4, right? At 2 the value would be 4. Suppose this is 2, the value increases and it becomes 4. Although it will be a straight line, at 3 the value would be equal to 6. Okay, so this is the function that you are just connecting. I don't have a scale here. Okay, so this is the value. So these values, see, so on and so forth. At 4 it would be equal to 8. I'm not drawing all the points. So this is 2, this is 4, and this is 6. Okay, so now here if you want to get the slope, so the first slope would be equal to, see, y2, this is the point, y2, see here the point was y2 minus y1. If you want to check this slope out, slope will remain constant. So it would be 4 minus 2 divided by 2 minus 1, correct? So this is your x2 minus x1. This point refers to your x2 and this point refers to your x1. And here this is your y1 and y2, right? You see the slope between the points remains constant. So this would be equal to 2 divided by 1. So the slope is 2. If you want to check between 4 and 6 also, you can see 6 minus 4 and 4 corresponds to this 3 minus 2. Okay, again the slope is your equal to 2, correct? Slope is this point, right? So slope will remain same. If you want to do with 6 and 8 also the same thing. 8 minus 6 is 2. Again 8 corresponds to 4. Okay, and this corresponds to 4 minus 3 would be equal to 1. The slope remains the same. So this is regarding about the slope. Now as far as this is concerned, right, if we do ramp, okay, r of minus t is concerned, so I told you inside the parenthesis this would be a fold, right? This would be a folding mirror image, right? This leads to a mirror image. Now here the slope, if you want to check, so here the slope, if you want, on the y-axis the slope is remaining positive, right? So it would be again your 2 minus 1. But on the x-axis the slope is varying, right? It is becoming minus 2 and minus of minus 1, correct? So if you want to see this slope, let's say this is your this is corresponding to 0 and this corresponding to 1 and minus 1. Okay, this is corresponding to 2 and this is minus 2. So you just have to get the slope, right? So slope is basically your y2 minus y1, okay, divided by x2 minus x1. So this is your x2 point over here, minus 2 is your x2 point and minus 1 is your x1 point, and this is your 1 and 2. Okay, so the same thing applied here. So this becomes your 2 and 2 minus of minus minus 2 plus 1. So this slope becomes equal to minus 1. The slope will be constant over here. So this was regarding the slope of this function. And same way you can do right shift, left shift and check the slope. Just like in the case of, suppose you want to write rt minus 2, right? So this will cause a right hand side shift. If you want to write rt plus 2, it will shift a left hand side, right? So you will shift it by, see, now your ramp begins from here. The ramp begins from t is equal to 2. This is your ramp from where it begins. Okay, now how do we perform any operation? Suppose I will show you some questions and how do we realize some signals. So we'll follow certain properties. I'll show you that in the next class. So we'll wind up this session. So in the next class I'll be showing you about this, how do we perform. Okay, so let me stop recording here.